Some of the new technologies coming along with Emulex in the HP environment, including single root I/O virtualization, SR-IOV. So I wanted to talk a bit about how that works and how it's relevant and how it's a progression from what we've been doing over the last few years. Currently, Emulex is shipping converged network adapters through HP. For example, the CN1100E is a 10 gigabit converged network adapter that has the ability to do fiber channel over Ethernet and standard 10 gig NIC over the same port. So it's converging or effectively virtualizing the physical card into multiple identities. Each physical card can be split into 2 network functions and 2 storage functions. What the operating system sees is 2 Emulex fiber channel or iSCSI HBAs along with 2 10 gigabit NICs, network interface cards. So this has been a fairly standard product available either as a LOM on the motherboard, a mezzanine card or a stand-up card for a couple of years now within the HP environment. And there are some progressions going on there to really be able to do more with the virtualization. So progressing from the converged network adapter where we split its identity into 4 functions, 2 NICs, 2 storage ports, with HP, the Flex Fabric and Flex 10 adapters from Emulex have gone further and allow us to break the card into 8 virtual identities per physical card. This allows us to have either 8 Flex NICs or 6 Flex NICs plus 2 storage ports on the card. So this gives us a lot of flexibility to be able to build into virtualized systems the ability to have one card that covers all the network requirements that you need. So take, for example, VMware, who would typically recommend having 6 1 gig NIC adapters. We can do that with one card by physically having just our 2 ports on there, break the card into 6 Flex NICs, 2 storage ports, and the operating system will believe and will see that it's got its 8 virtual functions available. So this allows us a lot of flexibility with a very simple set of cabling on the outside of it. And the flexibility comes not just from being able to do this dynamically, but by being able to change the bandwidth for each of those network functions on there. So you're not limited to multiples of 1 gig. It can be in multiples of 100 megabit per second up to your total of 10 gig. And so this gives us great flexibility, particularly when moving virtual clients around if we want more or less network performance on a particular channel port. So it's taking the basics of virtualizing the card and expanding it into the 8 functions that gives the Flex Fabric and Flex 10 card such a lot of performance and flexibility. Part of the technology built into the Emulex cards provided via HP and the Flex Fabric BE3 based solutions is single root I/O virtualization, SR-IOV. So taking a step back, with Flex Fabric and Flex 10, we had the ability to virtualize the physical functions of the card into 8 virtual identities. It's proprietary and therefore is limited to that particular environment. With SR-IOV, we have a technology that's applicable to any environment, and the reason for that is that it's a PCI standard. So the Standards Committee, the PCI Special Interest Group, PCI SIG, have defined how to split a card up into multiple identities beyond the 8 that we've had in previous generations. Now this is important because it allows you a lot more flexibility and a lot more capability within the card to do more. So for instance, we want to be able to provide virtual NICs, the Flex NICs, up to the guest operating system rather than just to the hypervisor. SR-IOV allows you to do that. SR-IOV allows you to break the card down into, in theory, 256 identities from the 8 previous versions that we had. And this is really by redefining what the PCI bus does. Now, in order to do this, we need specific hardware. So if we look at the new generations of HP servers, they have the ability to be able to support SR-IOV in conjunction with the Emulex Flex Fabric cards. So now we have the ability to be able to split the card into multiple identities because we've got the server, we've got the cards. The operating systems need to be able to support it as well because it's fairly intimately tied up with how the OS works. And at the moment, we have full capability of doing this under Red Hat, SUSE, Zen, and coming soon, we're going to have the ability to be able to do it under Windows 8 as well. So with the Linux operating systems, the KVM virtualization tool uses SR-IOV today. We can set that up. And the cards that we're providing today via HP have the ability to do that today, to be able to do SR-IOV. So it's a very flexible technology and an industry standard, which means it now goes outside of the closed environment of a particular server and is a generic tool across any network architecture. So to explain a bit more about how it works, traditionally in a virtualized operating system such as VMware or KVM, the hypervisor, which is the core of the operating system, is communicating with the hardware card, but is generating effectively virtual NICs to present up to the guest operating system. So the guest OS in your virtual clients will see what appears to be a VMware NIC or KVM NIC that's generated just as a pseudo device on there. And so all the I/O goes through the hypervisor. So everything can, in theory, be restricted via the hypervisor. So that's a potential limitation that we have, in that everything goes through the hypervisor. We have a very simplistic view of these cards. We have no visibility of what the real hardware is, and it constricts the way that the network is capable of moving workloads around, particularly in a large distributed environment. With SR-IOV, because we can have lots of identities with the card, we have enough identities to be able to assign each guest operating system its own 1, 2 or more virtual identities out of your 256 pool on the card itself. And it's not just about mapping the physical card to a virtual identity, it's about presenting the virtual identities all the way through to the guest operating system, effectively bypassing the hypervisor. And so if we compare to what we did previously, now the guest operating system sees what it thinks is its own personal Emulex HP NIC adapter. In the past, what it saw was a virtualized model of it, but now we're seeing what appears to be the same card, and this gives us a lot more flexibility in moving workloads around. We have the ability to be able to migrate virtual machines across much larger networks. And also have better performance out of it. And the performance is an important part because we're now bypassing the hypervisor. As we're adding more and more virtual machines in today's more powerful servers, we don't want to be restricted in terms of I/O performance. SR-IOV is a tool that allows us to go beyond that and give us more performance capability. So to summarize, SR-IOV is a technology which moves beyond the proprietary techniques that some of the alternatives have, such as Cisco, to have an industry standard method of dividing a card up into multiple identities. So this really gives us a lot more performance, a lot more flexibility, and a lot more scalability in a modern data center where the workloads are being distributed. We're putting more workloads on each physical server. SR-IOV as a technique is giving us ways to really take advantage of the server performance and the distributed networks which are becoming more common in today's environment.